Greetings to all. I thank the management to giving this opportunity to present the lecture on Introduction to Data Structures. So I am BALASUBRAMANI, working as an assistant professor in the Department of Computer Science and Engineering. Today I am going to discuss on data structures. Data structures is very important course for all the undergraduate and postgraduate students, not only for computer science and engineering students. It is common for all the all these circuit branches. We are going to see for the outline of this presentation. Data structures, we are going to see the basics of data structures and the classifications of the data structures and what are the examples of data structures. And we are going to discuss the important data structures like list, linked list, stack, queue. First we are going to see what is data. So we know that data is very important as far as the computer science is concerned, because without data we cannot do anything in computer science. So if you talk about computer science, then we have to understand why the data is needed in computer science. So data is used by almost all the applications or programs, and it takes the input as data and process it, temporarily stores, and finally output results the output. So this is the data usage in computers. So we can understand data by examples like numbers. So numbers is said to be a data, and characters. So these are all the examples of data. If you store numbers, then you have to define what type of this data is, so that the computer allocates memory and it is easy for us to process it. Similarly for character, so numbers take some size. Similarly for characters, and each has its own set of values. So we have to define what is number and what is the size of the number and what is the maximum value that can be stored using this number. And structure is another term which we have to understand. Structure is nothing but a combination of data types. So data can be either number or character or any other types like this, and structure means it combines these various data types, like numbers and characters can be combined, and it can be called as a single data, right? So now we are going to see the definition of data structures. So how can we define the term data structure? So data structure is the combination of elements in which each is either data type or the collection of data types. So we can say a single data type as a data structure, or we can combine the several data types into a single unit and we can term it as a data structure. And we should know something to data type. So we are talking about data structures. To understand the data structures better, we start with what is data type. So data is classified into various types. So we cannot say all the data of same type. So each data is having their own values and own set of operations on it. So data is classified into types. A domain of allowed values. Data type is a domain of allowed values and a set of operations on these values. For example, number, if you take number, it has its own values, say 0 to some numbers or 1 to some values, and what are the operations that can be done on the numbers, that is also has to be specified, so that operations will be carried out by the computer without any problem. Numbers can be added, numbers can be subtracted, and so on. Similarly, if you take other data types like characters, so if you take characters, then characters can be characters or string. String is nothing but a collection of characters, is another data type. If we take string, then we can perform string comparison, string concatenation. String comparison means one string is equivalent to other string or not. String concatenation means we can append the second string with the first string. So these are all the possible operations on these data types. So if you take data structures, it takes both a set of values and also the operations on it. So we have to concentrate on these aspects to understand the data structure. And this is the formal definition of data structures by Wikipedia. In computer science, a data structure is a particular way of organizing data in a computer so that it can be used efficiently. So data structure is used to organize the data. So why we have to organize the data? So if you organize the data so that it can be accessed quickly, so that it can be accessed efficiently. So and so that it can be used efficiently. Efficiently in the sense the memories has to be utilized properly. So we have to define data structures so that we can access quickly as well as we can use the memory effectively. And this is the need of data structures. So we have to organize the data. As I already said, data has to be organized so that it can be used efficiently. Used efficiently in the sense, if you organize the data so that it can be accessed in a faster manner, and it is used to create more efficient programs. So without data structures we cannot create efficient algorithms or programs. So by organizing the data we can able to implement efficient algorithms or programs. And we should understand how the data is organized. So I told that data structure is used to organize the data. How it can be organized? So we can different ways of organizing the data as listed out. So we can have the data in a continuous manner. This is one type of organizing the data. So data can be stored continuously in the memory. And then why we are storing the elements continuously means so that we can access the elements one by one without any delay. So if we know that second value is stored immediately of the first element, then after accessing the first element we can easily access the second element, because the second element is stored adjacent to the first element. So this is one way of organizing the data, and we can instead of this we can organize the data in some other manner, like we can store one data here, one data there, and so on, and we can combine, we can provide the link the data stored here and there. So one data is available means it has the information of the next data where it is. So by using this way also we can organize the data. And another popular way of organizing is you can store the element using some formula. Formula means, so this you have to apply the formula to the data, then that formula returns where the place for the data has to be stored. So these are all the popularly used methods of organizing the data. So data structures deals all these things, how data can be organized. And if you take data structures, definitely it has two requirements. One is space, another one is time. So space means how much space it takes to be stored in the memory, and time how much time it takes to access the data if you use this particular organization. So these are the two important requirements for any data structures if we design, right? Space for each data item it stores, and time to perform each basic operations. So basic operations means I told if you take numbers, then the numbers can be stored in a continuous manner, or the numbers can be stored in different locations, and it can be linked by some pointers, and you can use formula to store the numbers in memory. So if you insert element, or you can modify the element, you can delete an element. So these are all the possible operations that can be done usually in the computers. So we need data means then we can add the data. If you want to modify some data which is already stored, then we can use the operation called modify to modify the data. So these are only set of operations. So for each operation how much time it requires, that is also one important criteria when designing the data structures. So time and space, these are the two important factors by which any data structures can be analyzed. So next we are going to some examples of data structures. The first example or simple data structure is said to be array. So array is a homogeneous set of values. All the values are of same type and the elements are stored in a continuous manner, that is the array. And another important data structure is a linked list. So linked list is also a collection of elements, but the elements are stored in a different memory locations and it can be linked by using the pointers, and you can insert and delete the element anywhere in the linked list without any problem, whereas in the case of array you can store the elements in a continuous manner, but it takes more time to insert or delete a particular element in the array. So we will see the example to understand this point later. And stack is another data structures in which the elements can be inserted and deleted at only one end. So there is a restriction to insert the element and delete the element at the particular end only, right? Say top of the end. And the queue is similar to a stack, but insertion is taking place at one end and deletion can be taking place at another end. So that is the difference between stack and queue. Stack, both insertion and deletion can be taken at one end called top end, whereas in queue the insertion is taking place at one end called rear end and deletion can be taking place at another end called front end. So these are all the popularly used data structures in computer science. And using these examples we can classify the data structures in different ways. So the first classification is linear data structures and non-linear data structures. So linear data structures is the one in which the elements are stored in a sequential manner. So without storing the first element we cannot store the second element and so on, store or access. Similarly, non-linear data structures means the elements need not be stored in the sequential manner, means that the elements can be stored in any order and it can be accessed in any order. Okay, and another type of classification is static data structures and dynamic data structures. Static data structures is the one in which the elements number of elements are fixed. That means the size is fixed. We have the restriction to store the maximum number of elements to the particular number. That is called static. Whereas dynamic data structures means we can store or we can remove any number of elements according to the requirement. There is no restriction in the number of elements. If we want we can add the size, increase the size. If you don't want then we can reduce the size. That is possible in dynamic data structures. So these are the classifications of data structures, and this is what the introduction. With this background we can go into the actual data structures, how it can be designed or how it can be implemented. The first data structures we have to understand is list. So list is the basic data structure. The meaning of list is the collection of data or collection of elements, right? And we can implement this list using a simple array, or we can use linked list to implement this list. There are two types of implementation of list. One is array and another one is linked list. And almost in all data structures the important operations are insertion, deletion and locate or find. These are all the important operations by which all other operations can be performed. First we see the array implementation of list, because array is simple to implement and easy to understand. That's why we have taken array to implement the data structure called list. So as we know that array is nothing but a collection of homogeneous data. Homogeneous means same type. All the data are of similar type, and the elements are stored continuously. The elements are stored continuously in the array. The advantage of using this data structure is it is simple and easy to understand. So we can easily understand, and it is easy for us to implement, and the drawbacks is difficult to insert the delete data. So we will take one example to understand the data structures in a better manner. So and it is of fixed memory size because it is coming at a static data structure. The size is fixed. Once the size is fixed, we cannot insert more than the size. And the next data structure is linked list. So linked list is one type of implementation of list. So here we can store non-homogeneous data. Non-homogeneous data means we can store different data types together, like integer, string, etc. So you can put integer and string as a single object. So we can call that combination of integer and string as a data, right? So data are stored randomly and are linked using pointers. So this because of this we will get some advantages, like the one which is shown in the slide, that is it is dynamic data structures because the size is not fixed, so it can be increased or it can be reduced according to the need or according to the requirement, and it utilizes the memory efficiently. So efficient memory utilization is possible by using linked list because the elements are stored in a non-continuous manner. Wherever the free space is available, the data can be stored in that free space, and they are linked by using the pointers. And insertion and deletion are easier than array, because in array the elements are stored continuously. If you want to insert an element in a particular place, the remaining elements has to be adjusted so that we can get the place for adding the element in the particular place. Similarly, if you delete the element from array, then all other elements has to be adjusted so that the elements are in the continuous manner. But because of that, it takes more time to insert or delete. The same insertion and deletion can be done in linked list with less time, because the elements are stored in a different memory locations. If you want to insert a particular element into the linked list, then you have to provide just link where the element has to be stored, next element has to be stored. We have to adjust that information to add. Similarly, deletion means if you want to delete a particular element, only we have to change the address of the element in the previous element. So because previous element contains the address of next element, so if you want to delete a particular element, that instead of that address you have to store the next address in the previous node. That is the single operation enough to add or delete, and it is faster access because all the elements are stored using assist using pointers. We can perform the operations faster. And we are going to see the types of linked list. So we basically have three types of linked list, namely singly linked list, doubly linked list, and circular linked list. So singly linked list means it contains the non-homogeneous data, and the elements are stored in different memory locations, and they are linked by using pointers. So how it can be implemented using singly linked list? So singly linked list is defined as the set of collection of nodes, set of nodes or collection of nodes. So node is nothing but self-referential object. Self-referential object means the node has the member which is again the same type, that is again it is a type of node, that is called self-referential structure. So self-referential structure contains the member as the similar data structure. So node consists of singly linked list. If you take singly linked list, it's a collection of node where each node consists of two fields or two parts. One is data and another one is address of the next data. So it consists of two parts, elements and the address part. The address part is used to point the next node in the linked list. So node has two fields, date and address, and the nodes can be joined like joined using pointers, and the end of the node is identified by the last node whose address field is set to null. So that is null pointer is used to identify the end of the list, and by using this structure we get these advantages. So it does not need movement of the elements for insertion and deletion as we did in the array, and the space is not wasted, because if you use array then the elements number of element size is fixed. For example, the number of element size is 1000, but if you store only 100 elements, then the remaining 900 spaces are not utilized. That space is wasted, but here in linked list the space is not wasted, because if you use 100 elements, then it takes only 100 elements size, 100 elements memory location, and the size is not fixed here. So whenever you require, you can add the elements as you want. Similarly, if you don't want the elements further, you can remove and you can shrink the size of your linked list, and it can be extended, reduced according to the requirement, and it is less expensive. And this is also has some disadvantages when compared to other types of linked lists, say double linked list and circular linked list. First we see the disadvantages, and then how the other types is implemented to overcome these difficulties. So it requires more space as pointers are used, and this is the disadvantages over array. So in array we haven't used pointers, so the space is not required much, only data is alone is maintained in the array. Here in linked list we have to maintain data as well as the address of the data. So it takes two memory locations, one for data and another for address, and different amount of time required to access each element. So this disadvantages is written by comparing with other type of linked list like W and circular. So we will understand these disadvantages when we discuss about W and circular linked list. So for each node it takes its time. For example, if you access first node, then it is accessed quickly. The same time cannot be required for accessing the last element, because last element takes more number of movements, so that we can able to access the last element, and only traverse in one direction, because each node contains the address of next node. So we have to go only in the forward direction, and because of this nature, the searching takes more time. So searching the first element is less when compared to searching the last element in the linked list. It depends upon the number of nodes used, number of nodes available in the linked list, the searching time may vary. And doubly linked list has three fields. I think I will explain using the board to understand the linked list concept. So first I talked about array. So array means the elements are stored in a continuous manner in the memory. Say for example 0, 1, 2, 3. So these are all the index. So the elements are stored in this manner, and the size is restricted. So size is restricted. This array consists of 4 elements, 1, 2, 3 and 4, 10, 20, 30, 40. So these values are stored in the continuously in the memory. Say for example this is 1010 in the location the element is stored, means 20 is stored in 1012, because integer, if you take integer, it takes 2 bytes in the memory. So next in the location 1014 contains 30, and in the next location 1016 we can store 40. So these elements are accessed by the index, and these elements are stored in the continuously in the memory. So the operation important operation of all the data switches are insert and delete and locate. The other name for locate is find or search. So if you want to insert any element in the list, Suppose so we can assume that the size of the array is 10, 0 to 9 locations. We can have the space. So if you want to insert the element, what we have to do is, suppose we want to insert the element in the second index position. So in the array, first you have to move all the elements from the size from the index place where we have to insert till the size to one place and next, so that we can get this place here. So the third element has to be moved to fourth place, and the second element have to be moved to second place, third place, so that we can get the space. So then if you want to insert, say for example insert 25 can be inserted here now. So to insert a single element, we have to move these two elements one position next. So if we consider a 1000 size array, number of elements is 1000. If you want to insert the element in the first place, so you have to move 1000 elements one place next. Similarly, if you take delete, if you want to delete the third element, if you want to delete, say for example first element 20, so you cannot remove 20 easily in the array, because the condition for array is the elements should be stored in a continuous manner. So 10, after removing 20, the 25 has to come here in this place 25, and 30 has to come on place previous, and 40 has to come to the 30th place. Similarly, the remaining elements has to be adjusted so that the elements are filled in the continuous manner. So this is how the insertion and deletion is performed in the array. As we understand, the insertion and deletion are taking place more time. And similarly, locate and find can be performed. If you want to locate 30, first we have to start with first element. So we have to compare whether 30 is equivalent to 10. If it is not, you have to move to the next number and next number and so on till the number is found, or we have to search the entire set of elements. Finally, we can say that the elements is present or not. So in the worst case, it takes n comparison if the size of the array is n. N comparison is required to say the search in worst case, right? So to avoid this drawback, we are implementing the list using linked list. So linked list is nothing but a collection of nodes where each node is consists of two parts. So this is called singly linked list. Singly linked list means each node consists of two parts. So this part is data part and this part is called as address part. So here we have the element say 10 for example, and this field is used to store the address of next node. Say for example we have the next node whose data part is 20 and the address of this node is say for example 1080, where this address of this node can be taken as 1010 for example. So here we have to store this address 1080, means that after 10 we have the node with the data 20. So likewise this address consists of the third node in the linked list. Third node for example we have 30 which is in 4040. In this location we have the third node and this address has to be stored here, so that after visiting this node we can visit this node whose address is 4040. So likewise we can maintain the linked list and the last node can be set to null. That means that is the last node in the list. So first node can be identified by using this special pointer called head, so which has the address of first node. So head consists of 1020. So using this starting address of the linked list, we can go to all the elements, we can access all the elements. So first node has to be stored in some special pointer called head, which consists of the starting address of the linked list. So head points to 1010. So we can have the data of part 10. We can access the data using this node, and next node is 20 because the address of 20 is stored here. Likewise, we can go and since this node doesn't contains any address, or it is set to null, then it means that is the last node in the linked list. So here we will see how to insert and delete. So if you want to insert a node, you have to create a node and you have to get the value data part for this node, and if you create the node, it is stored in some free space. For example, the free space of this node is 1040. In the address we have free space. We are allocating, we are getting the memory using the memory allocation method, and we are creating this node, and where we have to insert. Say for example, we have to insert after 20 as a third node. What we have to do is that in the second node's address, right? So you have to store this address, and we have to remember this address so that we can provide the link to the next node. So first you have to store the address of the next node. So this node has to be inserted in the place 3. Then fourth node's address has to be stored here. So fourth node address is what? 4040. That address has to be stored here, and this address has to be stored here. This address is 3040. So 20, already we have 4040. Instead 3040 we are changing. So the next node is automatically comes to here, and this address is what we have stored in the previous node. In the previous node the address is 4040, that has to be written here. So which represents this, and because of this operations, this link is broken. So this is insert operation. So only we have changed two pointers to insert a single node. Similarly, you can insert any node in any place using the 2 pointer adjustment. Next pointer, previous node's next pointer, and the new node's next pointer. Only we have to change address in these 2 address field to insert a new node. So this is the insertion. We have, irrespective of the number of nodes, we have to do only these 2 pointer adjustments to insert a new node. Similarly, delete can be taking place easier, because suppose you want to delete this second node. What we have to do is, this node's address is stored in the previous node, say this node's value 10. This address 1080 is stored. So if you want to remove the node, we have to store this address to the previous node. So this address is 3040. Node 20 contains 3040 address. That address has to be stored in its previous node, like this. If you change like this, then 10 contains 3040. It will goes to 3040. That is 25. And 25 contains 4040. It goes to here. So thereby this 20 is removed, and this memory can be deallocated and it can be used for some other elements. So this is how the deletion is taking place. So for deletion we have to change only one pointer, right? So now we can compare the insertion deletion with array over a linked list. So in the deletion or insertion in the array takes more time, because we have to move all the elements so that we can insert or delete. Whereas here that drawback is overcome. Only we are performing at most 2 adjustments, 2 pointer adjustments. So this is called singly linked list. And we will understand the other type of linked list, say doubly linked list. So doubly linked list means node consists of 3 fields. One field is for storing data, and 2 fields are used to store the address of next and address of previous nodes. So this field is pointer to next node, and this field contains the address of previous node, pointer to previous node. So this is called node in doubly linked list. So say for example 10 we have the node, the next address is 1040 and previous address is 2020. So address may be in any order, right? That is the advantage of linked list. You can have another node in any place. Say for example next node whose address is 1040, this node also consists of three fields. One field is for data, for example 20 is the data part, and this is the next node in the list. So next node you can have it in 2080 for example, and this previous node consists of this node 1040. This is the previous node. So 1040 means like this, and since we have stored the next part 1040, it means like this. So this is forward pointer and this is backward pointer. So each node consists of two pointers, one for the forward direction and one for backward locations. And 2040 means we have one node called whose value is 30 for example, whose address is 2080. So in this previous value we have to store this 1040. So each node consists of two addresses, one for next and one for previous, and this first node can be identified by head, whose address is, this first node's address is stored here. So for example address of this node is head address is 2020, this pointer, and this address is stored here. For example this is 880, so this value is stored here 8080. Head pointers next is 8080, so it points to this node, and this node points to this node, and this node points to 2080. So in 2080 we have one node, and the last node is identified by null for example. So null means we don't have any nodes after this. So this is a doubly linked list. Doubly linked list means each node consists of one address part and one data part and two address part. So because of this we can traverse the in both directions, both in forward direction and in backward directions. So we can go with 10, 20, 30 etc. Similarly if you are in 30th node you can also go in a reverse manner, 30, 20, because this previous node's address we have stored in the 30 itself, so we can come in the reverse direction. So because of this we can perform the operations faster than single linked list, and the drawback of the double linked list is that more space is used, because for each node we have three fields, one data field and two address field. So more number of spaces are used for doubly linked list than singly linked list. And the third type of list is circular. The circular linked list, so it is similar to a linked list. We can use a single linked list or double linked list. We can modify the singly or doubly into circular. For example, if we take singular linked list, the structure is like this: 10, 20, 30, and suppose this is the last node in the list, means the address part is made to null, and this arrow mark specifies that this address is stored in this node, next node's address is stored in the previous node, and this node points to next node, means that this address is stored in this node, and so on, and the last node points to null. So this is the single linked list. Circular linked list means instead of making the last node to point to null, you have to make the last node to point to first node. The address of the first node is stored in the last node. So if you modify the structure like this, we can go in a circular manner. So here we cannot specify which node is starting and which node is ending. So all the nodes are equal. Means that you can go with 10, then 10th node, next node is 20, 20th second node is 30. So if we are in 30, 30th next node is 10. So there is no starting or ending in circular linked list. So this is another type of linked list. This type of structure is useful when some applications request this type of linked list, circular linked list. So if you take a singly linked list and you can compare singly with the circular, in singly if you are in last node, then you cannot come to first node, or even you cannot come in the reverse manner, because singly linked list we can go only in one direction. If you take circular linked list, since we have the pointer to the first node, if you are at the last node, there is no problem in coming back to first node. So the access speed is higher than singly linked list, because we can go only in one direction. Here also we are having only one direction, but we can have the connection between the last node and first node. So if you take a doubly linked list, you can form a circular, then it is called doubly circular linked list. So we will get both advantage of circular linked list and doubly linked list using circular doubly linked list. That is another type of linked list, circular doubly. So these are all the important data structures linked list. We have seen singly linked list, doubly linked list and circular linked list. Doubly linked list, we have the advantages like traverse in both directions, and we can, by using this, we can reverse the elements easily. So first to last and last to first is not a problem. And disadvantages of doubly linked list, as I said, it requires more space, because we have used 2 pointers in each node. It requires more space to accommodate the pointers, and insertion and deletion takes more time because of 2 pointers involved. And the third type of circular linked list is circular linked list, where the last node is made to point to first node in the list, first node or front. And advantages is traverse is easy, because from any position we can reach any other position, because all the elements are connected in a circular manner. And first to last and last to first is easier, because we have the connection from last to first. And disadvantages, not easy to reverse. So reverse is not easy, because we can forward in only one direction when compared to doubly linked list. And infinite problem may occur if proper care is not taken. So in implementation for circular linked list, we have to take care of connecting the last element with the first element, and we have to identify which is the starting node in the circular linked list, so that we can avoid the problem. And when we supposed to use a linked list when compared to array. So in array, as I told, the size is fixed. When the number of elements is not known in advance, then we have to go with linked list. So you have an unpredictable number of data elements. The best choice is linked list, and if you want to perform the element operations in a faster manner, then at the time also you can use linked list. So this is the situations where we have to prefer linked list over array. And another data structure is nothing but stack. So stack is a popular data structure in which the insertion and deletions are restricted to be performed at only one end, called top. Okay, we can implement like a linked list. There also we can also implement a stack. We can create a list of nodes where each node consists of data and pointed to next node, and you can insert only one end called top. So if you want to insert, then you have to insert at the beginning, and if you want to delete the element, you have to delete from the beginning. So if you do like this, then it forms like a stack. Stack we can understand by taking this example. So pile of dishes. So or another example we can say bangles. So bangles can be added or removed in a particular fashion. So you can insert one bangle after another bangle, and you cannot remove the first bangle without removing the second bangle. Okay. So likewise you can take another example, arrangement of books or arrangement of CDs in a vertical manner. So you can insert one over another, you can add the CDs in a CD stand one over another, and you cannot remove the first CD without removing all others which are all on the top. This particular structure is used in some applications. That is why we have implemented, we have talking about this data structure. So new nodes can be added and removed only at top, and it is similar to pile of dishes, and we can say the principle of stack is LIFO, last in first out. So which element is inserted for last, that will be removed first. So we have restricted that insertion and deletion can be placed at only one end. Because of this we will get this fashion, last in first out. And bottom of stack is indicated by the link bumper to null, as we implemented in linked list, last node point to null. The bottommost element is point to null, that means that is the last element in the stack. And we can say that it is a constrained version of linked list, because by using linked list we can implement stack. So insertion and deletion, if we take insert at beginning and delete at beginning, then it forms like a stack. And the operation of the stack are called as push and pop, because of this particular way of inserting and deleting. So push means adding the new node to the top of the stack, and pop means removing of the top element from the stack. So these are the two important operations of stack. So the other operations are quite normal, that is you can check whether the stack is empty, whether the stack is full. You can search the particular element, because we know the pointer, top pointer of the stack, by which you can search any element through the pointers as we perform the search in linked list. And the next data structure is called queue. Queue is similar to stack, but the insertion is taking place at one end and deletion is taking place at another end. So because of this we will get some advantages like stack. So this particular fashion of adding and removing is useful in some applications. Examples of queue is normal queue, as we as we see in any practical queue applications. So supermarket checkout line is the best example to understand the queue. The persons who are in the first will be serviced first, and the persons can be added at the last, and because of this it is called as FIFO, first in first out. The first whoever getting first, that will be goes first. And nodes are removed only from the head, and nodes are inserted only at tail. So tail means back, head means front. And the operations are called as NQ. Adding the element at rear end is called as NQ, and deleting the element from the queue is called DQ. And these are all the important operations. Again, queue can also be implemented by using a linked list itself, adding the inserting the element at beginning and deleting the element at last. So if you perform the operations like this, then we will get the FIFO policy. That is, if you insert beginning and if you delete the element at last, then the elements will be inserted and it will be goes to last, and the elements deleted from last. So we will get the queue discipline in the linked list by performing restricting the insertion and deletion operation in a particular end. Insertion at one end means deletion can be taking place at opposite end. And in types we have in queue we have different types, like simple queue, double-ended queue. Double-ended queue means in both ends we can insert and delete. So in normal queue, insertion is taking place at one end means deletion is taking place at another end. In double-ended queue, insertion and deletion can be taking place at either end. Say for example, in front end also you can insert and delete. In rear end also you can delete and insert. So that type of queue is called as double-ended queue. And next type is called circular queue. Circular queue means the both ends are connected together, and it forms like a circular. So that is called circular queue. So once you are entering, once you are entering, then it will be connected like a circular. Then the last person can immediately next to first person. So like circular linked list, we will get a circular fashion of arrangement of elements. So we will get advantage of circular queue for some applications. And priority queue is queue, and the deletion is deletion or insertion with priority. Means that the elements are inserted in a normal principle, like FIFO principle, and the deletion who is getting higher priority will be deleted first. So we will assign the priority for each element in the list, and based on the priority the deletion is taking place. Or also we can do it in the other way, you can insert the element based on the priority. So both the type of implementations are available. And these are the types of queue, and I think I have covered the basic important data structures like linked list, stack and queue, and we have seen the implementation details of these data structures. Using these data structures we can store the data which we are interested in. For example, if we take a college, the students information has to be stored. If you take students consist of students number, students name, students address and students marks or score. These information is common for all the students. So we have to use any one of the data structures, and the data has to be stored so that it can be accessed or processed easily. Similarly, for employee details can be stored using linked list, or it can be stored using stack or queue. So if you prefer to use linked list, then you can add any number of employees as you want, and if some employees they are going out, you can remove it without affecting the other employees details. So this is the practical applications where we can use these different types of data structures. So data structures is very important for software developers or programmers. So bad programmers worry about the code, so how they can write the statements, how they can write the codings, whereas only the good programmers worry about the data structures and their relationship. So by using this quote we can understand the importance of data structures. So thank you for the management to give the opportunity.